actually a researcher. I'm a professor. I'm head of the Institute of Wealth and Asset Management at the Zurich University of Applied Sciences, School of Management at Law in Switzerland. I'm a former market professional, so I have gained 15 years of work experience after getting my PhD in physics. I've been working in investment banking, in derivatives, and then later at a managed futures fund. So at our school, I'm involved, besides teaching, in applied research. We work together with asset managers and also with other universities or with banks to do projects, innovation projects, because often market practitioners are interested to try out new methods to get some more insights, and then we help out. At the conference is on interpretable machine learning for diversified portfolio construction. This is based on a joint research paper with Munich Re Markets and with NVIDIA. In this article, we construct a pipeline to benchmark investment strategies against each other. We explicitly pick two variations of risk parity, which is equal risk contribution and hierarchical risk parity. We use an interpretable machine learning concept, also called Explainable AI, to compare the robustness of both strategies and to back out implicit rules for decision making. So we backtest the two investment strategies against the empirical data set and also using about 100,000 bootstrapped data sets. Then we use XGBoost to regress the spread between the Kalmar ratios of both strategies against features of the bootstrapped data sets. And then we explain this Kalmar ratio spread with statistical features of both bootstrapped data sets. And so this helps us to understand what the market drivers for the different performances are. And our findings are that indeed hierarchical risk parity is more robust compared to equal risk contribution, not only in the empirical data set, but also in the bootstrapped data sets. And we find out that we can attribute the Kalmar ratio spread, especially to univariate drawdown measures. In learning applications in investment processes happen at different stages of the investment process. We can apply these methods, for example, in the security selection step, where it's about including more data than just financial statements and market data, where it's about including also alternative data, maybe unstructured data, maybe diverging ESG data, or even geospatial data. Then the next step would be the asset allocation. So my presentation is an example of an ML application in this asset allocation step. Of course, it could also be used for tactical asset allocation, for market timing, and of course, it could also be used for improving the transparency. This is also this, say, explainable AI concept we are talking about would be an example of that. And in the next step, the actual, say, execution step, of course, also ML algorithms could be used, say, to optimize the execution to reduce trading cost. A different, say, application would be sentiment analysis. So this could be used either in the security selection step or in the tactical asset allocation step.